Now let's see this question. If capital A equal to 1, 2, 3, so on n, 1, 2, 3, so on n, which means A is containing n elements, then the number of reflexive relations possible on A. They are not asking about the smallest or the largest. They are not asking about the number of elements present in the smallest or the largest. That is a different kind of question. Here they are asking about the number of reflexive relations which will be present in total. Okay. So, in order to answer this, let's go to a smaller question and answer this one. So, what they are actually trying to ask is, let us say A equal to 1 comma 2, right? Then what can you say about A cross A? A cross A is 1 comma 1, 1 comma 2, 2 comma 1 and 2 comma 2. Now let's try to see how many reflexive relations can you write on this. So the smallest reflexive relation should contain all the elements of type x comma x. What are all the elements of type x comma x here? 1, 1 and 2, 2, right? And now other reflexive relations can be formed by adding more elements to this, which means we have to find out all the supersets of this set R1, then we are going to get all the reflexive relations. So in this case, what are the other elements you can add? See this. Now 1 comma 1 and 2 comma 2 should definitely be there, otherwise the relation cannot be reflexive. Now other than this, you try to add the other one. So what is it? So I can add 2, 1, or let me add 1, 2 first. So 1, 2, right? Or add, so these are different relations in total, right? So 1 comma 2, 2 comma 2 and then 2, 1. This is a different relation from the existing relations. Or 4. Or 4 is 1 comma 1, 2 comma 2, 2 comma 1, 1 comma 2, right? Which is nothing but it is A cross A itself, right? Therefore, this is the smallest relation and this is the largest relation, but in total there are 4 relations which are reflexive. So for a element containing, for a set containing 2 elements, the number of reflexive relations we can form is 4, R1, R2, R3, R4. Now just think about how we got this. So the basic rule is simple. In order to make a set as reflexive, a relation as reflexive, we have to include in that set all the elements of type x comma x, which means 1 comma 1 and 2 comma 2 should definitely be included. There we have no choice, right? But then among the remaining elements, we may or may not include them, which means for this element we have 2 choices. We may include it or we may not include it. And for this one we have 2 choices. We may include it or we may not include it. Therefore 2 into 2, 4 sets are possible. Are you getting this? For all the elements of type x comma x, we will not have any choice. That is why 1 and 1, right? And for the remaining elements, you please watch the complex and combinations where I discussed about such questions. Okay. So for this one, we don't have any choice, and for here we have 2 choices. That is why 2 into 2. That is why we got 4 sets. Are you able to get this? Now let us say A is containing 3 elements, 1, 2, 3. How many reflexive relations do you think will be possible? So in order to answer this, we have to find out all the elements of this set A cross A, right? So how many elements will be present in this set? We have 1 comma 1, 2 comma 2, 3 comma 3, and like that we have 1, 2, 3, 4, 5, 6. Totally we have 9 elements, isn't it? Now for a relation to be reflexive, we have to definitely include these 3 elements, right? We don't have any choice. We have to definitely include these 3 elements. Therefore we don't have any choice there. We have only one option, one choice: include them. For the remaining elements, we may or may not include them in the set. Therefore for all the remaining elements, we are going to have 2 choices. So we have to multiply 2 into 2 into 2 into 2 into 2 into 2, which means for A equal to 3, we are going to get 2 power 6, 2 power 6, which means 64 reflexive relations. We cannot write them all like this. I cannot show you all them like this. Therefore we are going to use the method of counting. I am not going to enumerate it all, right? So now if you observe this one, how did we get this? I have included all the elements of type x comma x, and the remaining elements, they are all going to give, we are going to get 2 choices for them. Therefore the answer is going to be 2 power the number of remaining elements. What are number of remaining elements? Non-diagonal elements. Why? Diagonal elements are 1, 1, 2, 2, 3, 3. Let me call such elements as diagonal elements because they happen to form the principal diagonal of a matrix if you draw them in a matrix, right? So we have to find out the number of non-diagonal elements, and 2 power number of non-diagonal elements is going to be the answer for this question, right? So how can we find it out? Now see this. In case if cardinality of A is n, then what will be the cardinality of A cross A? It will be n square. We know this, I already told you, right? So the total number of elements that can be present in A cross A is going to be n square. Now out of these n square elements, how many elements will be diagonal? The number of diagonal elements are nothing but all the elements of the form 1, 1, 2, 2, 3, 3, so on n. So if we have 1, 2, 3, 4, so on n elements, then the number of elements of the form 1, 1, 2, 2, 3, 3, so on n will definitely be only n, isn't it? Therefore the number of diagonal elements is going to be n. If this is the total number of elements and if this is the total number of diagonal elements, then how many elements will be remaining? The number of non-diagonal elements is going to be n square minus n, right? Therefore the total number of relations which will be reflexive is going to be 2 power n square minus n. Why? Because if a set has to be reflexive, if a relation has to be reflexive, we are going to include all the n elements for sure, and for the remaining n square minus n elements we have two choices. We may include them or we may not include them. Therefore we are going to get 2 power n square minus n such elements. So the total number of reflexive relations on a set A having n elements is going to be 2 power n square minus n, right? Now the question is, how many number of relations are possible which are not reflexive? So how can we answer it? This is the answer for the number of reflexive relations, 2 power n square minus n, right? Now how can you answer the question, how many number of relations will be possible on a set A containing n elements which are not reflexive? Then how can we find out for that question? It is nothing but the total number of relations minus total number of reflexive relations, right? So for this you should understand how many total number of relations are there. The total number of relations I already told you is going to be 2 power m into n if A is going to be m and if B is going to be n size, in case two sets, right? But here in this case the total number of relations from A to A is going to be 2 power n square. So 2 power n square is the total number of relations, out of which this is the total number of relations which are reflexive. Now we have to subtract this total number of relations minus the total number of relations which are reflexive. So what is this? 2 power n square minus n. If you subtract this, this is the total number of relations which are not reflexive. Are you getting this? So how did I get this 2 power n square as the total number of relations? Same. If you have n elements as the cardinality of A, then A cross A is going to contain n square elements, isn't it? Now, in order to form a relation, a element from these n square elements can be present in that or may not be present in that, right? So since we have n square elements, then each element is going to have two choices. So 2 into 2 into 2, so on n square times, that is going to be 2 power n square. So the total number of relations is going to be 2 power n square. Now from this total number of relations, if you subtract the number of reflexive relations, then we are going to get the total number of relations which are not reflexive. Okay? Fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries, for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.